So in this video, I will be going over integration by parts, why it works, and then just a couple quick examples. So here's the big idea that if you have two functions, and for some reason, integration by parts often uses the letters u and v, not that it actually matters what letters you use, but if I have two functions and I take the derivative of those two functions, we can rewrite it as u prime of x times v of x plus u of x times v prime of x. And so in the fundamental theorem of calculus, we are allowed to use the integral to cancel out the derivative. So what I'll do is take the integral of both sides of this, and then I have that u times v is equal to the integral of u prime v, and I can distribute the integral to two separate pieces, plus the integral of u times v prime. And what we do is we just subtract this chunk from it, so we get that u times v minus the integral of u prime times v is equal to the integral of u of x times v prime of x dx. So how is this idea helpful? Sometimes you will see an integral that comes in this form here, where you have a u and a v that don't have much to do with each other. So it's not like a substitution problem where one of those is the derivative of the other one. They're just two separate functions, and it can be transformed into this part over here. So what I want you to notice is that one piece of your integral gets derived, and the other piece gets anti-derived, and you should end up with something easier as a result. So here's kind of a classic example. If you have an integral like x times e to the x dx, there's no substitution that will help here because they don't have anything to do with each other. But if I say that u of x is x and that v of x is e to the x, then u prime is equal to 1 and v stays as e to the x. So I can use this, and now I'm rewriting it as the left-hand side, u times v minus the integral of u prime 1 times v of x again, e to the x dx. And the integral here is just e to the x. So we get x e to the x minus e to the x plus c there. And that is your actual integral. You can always check that it actually works by taking its derivative. And if you take the derivative of x e to the x minus e to the x plus c, you get a product rule. So 1 times e to the x plus x times e to the x minus e to the x, and you can see you get back to your original function. Okay. One last example here. If I have the integral of something like 3x sine x dx, I can say u is 3x because it gets easier when I take its derivative. I can say that v prime is sine of x. A lot of times you'll see people write it using, instead of v prime, they'll write dv. So then du is 3 dx, and v is negative cosine x. By the way, all I'm doing is just writing this as if it was dv dx, and here writing this as if it was du dx, and then just solving the differential form. So then that's going to equal u times v, and I'm just moving the negative in front, minus the integral of v du. And doing the integral of this, double negative is a positive, Integral of cosine is sine. So I have negative 3x cosine x plus 3 sine x plus c. So that's integration by parts for you. Please let me know if you have any questions. Happy to help out.